Hello, guys.
Can you hear us?
Yes, I can hear you.
Can you see the presentation and the video feed?
Yes. Oh, you have a subtitle?
Can you see both of them?
Video, sorry, subtitle.
Okay.
Yes.
Great.
Right. Yeah.
So let's start. Yeah. Hi. I'm Jakub Nat, and I'm the founder and the technological leader of this project.
Yeah, and my name is Adam, and I'm the organizational head of this project.
Yeah. So our project is the Project Picoballoon, which we are developing in collaboration with the SFN. So let's start.
So what you can, or like what you'll learn today is like how was the setting before the project, what was the problem we faced, and what's the inspiration for it, as well as what is a Picoballoon, just the basic definition, and the timeline and highlights of our work. So what do we have now, and our current plan is to start.
Yeah. So let's continue.
Yeah. We're trying to.
Yeah. So I started this project about 2 years ago, and in November 2018. And so this is kind of my setting before the start of the project. So before the start of this project, I was already doing electronics for 5 years. So that means I had a lot of experience with modules and Arduino and stuff like this. And they may be people, some of you may be in a similar situation right now. But the thing was that I didn't actually have any experience with international collaboration. I didn't focus on any specific area of engineering. I didn't do RF or sensors. I mostly worked alone, which is limiting. And my projects were very short-lived and didn't have any deeper purpose. So, and also kind of different things that also the project had smaller publicity. So we can continue.
Yeah, so what do you guys think is on this picture? I think most of you know that this is a meteorology stratospheric probe or a balloon that is used in all of the countries for measuring meteorology data, and it costs about 300 euros. So we faced a few problems, or like we found a few problems with this, and those are the problems.
Yeah, so as Adam said, these stratospherical balloons are launched by many people. So the biggest launcher of stratospherical balloons are the meteorological organizations around the world. So these stratospheric balloons are crucial to gaining weather data, which is later on used for creating weather models, which when you look up weather, it's also made from this data. These weather balloons are launched from 900 locations around the world, so that means 1,800 balloons each day the full year. And this is not the only people. You also have schools, students, research institutes which launch this for scientific purposes. And you also have like private research companies which use this for any of their own purposes. But the thing is, like payloads for these high altitude balloons, as they are called in the field, can be really cheap. The electronics you can build the electronics for like 50 euros or dollars. Yeah. But the problem comes that when you want to actually launch the balloon at like half a kilo, then you need a large latex balloon to launch it. And this latex balloon can cost a lot of money. So it's around 50 euros. But when you want to launch it, you also need some filling gas. And when you are a professional, you can use hydrogen, but it's highly dangerous to use it if you are just a normal student. So you need to use helium, and helium is very expensive. So the filling gas, which literally just blows up in the air, can cost many times more than the whole probe. And the last thing, which is not really a problem by itself, is that the probe, but it's a disadvantage, is that the balloon only goes up, it goes bigger, it pops, and falls down in around 2 hours. While Picoballoons, as we will learn later, can go for much longer. So let's continue. Yeah, so what's a Picoballoon? A Picoballoon is a probe. So let's see it. And this is how the probe looks together with the balloon. And let's talk about some of the features. So a Picoballoon is ultralight. So our current probe is only 1 gram. And it's very low cost. So one launch with the whole probe, but also the balloon and the helium can cost less than 50 euros. The third thing is it has a power-independent system. So this means that it uses solar power for powering all the electronics. So it can go up for months. It's also durable, so it can fly for long periods of time, can measure important scientific data, and send it to us through very long distances, so hundreds of kilometers. Yeah. This all started, as I said, I got the idea in November 2018, and I started the development of the first probe in January 2019. So this is how it looked. It's very simple. As you can see, there is a large module similar to an Arduino, which also has an RF chip, which transmits all the data. And it was very bulky. It was 19.5 grams, and it couldn't measure anything. It was just working for a couple of hours and transmitting just like a radio chirp signal. But later on, yeah, this is the launch. We needed to launch this with 2 balloons because it was so heavy. But later on, this is the improvement version. So yeah, it improved in many aspects. So it's not a module anymore. It's more of a it's just a single PCB with all the components soldered on it, except for the sensor, of course. And it was only a bit lighter, but many of the components were the same. This is the launch, and yeah, we can go to the third probe, or 2 versions of the third probe. So these were one of the longest flights. So it's a very similar design as the previous one. It's just a bit smaller, and thanks to better planning and also maybe some luck in the flight, one of them at least managed to go for about a week and has flown nearly 5,000 kilometers from Slovakia to Iran. And the next probe, yeah, this is a video. Maybe the moderator can let me know if it's be able to play. Yeah. So, yeah, this was a year ago.
Yeah, it's almost unbelievable, yeah.
This is the fourth version. had some improvements. We were trying to test GPS on one of the flights. So as you can see, both version 3 and 4 had 2 flights, nothing being added, and both of them were, I mean, they were pretty long flights, and one of them was pretty cool because it was the first probe to be actually found. We had 2 probes which were found, and this was found in the Dagestan Republic. And so we can go through, yeah, this was the place of the launch. It was during a space conference in the Czech Republic. And yeah, so what happened is that the balloon flew from Czech Republic through Poland to Lithuania. And then these very, as you can see, the gust winds carried the balloon back to Slovakia through the eastern Slovakia. And then we followed this path, and then we lost contact near Kiev and Ukraine. But as we follow, then you can see here that someone sent us a message in Russian. And as we got talking through Google Translate, of course, because they didn't bother, so I did. Then we managed to communicate everything. They sent me their PayPal mail, which was called Ganja Mafia. And so on the next screenshot, you should be able to see that I sent 2,000 rubles to Ganja Mafia to get my probe back from Russia. So that was a lot of fun. But in the end, we got it, and we have it in a showcase. So we can show the probe off. Yeah, this is the last successful launch, actually, which was done in March this year. And yeah, we have successful GPS running, the GPS from uBlocks, which is now sponsoring us, and we measured some interesting parameters like the flight speed, which was at the time, because they were windiest, around 170 kilometers per hour, which is a lot. And going on, yeah, this was the place of the launch. So in Czech Republic, they actually started a competition called the Picoballoon Challenge, which is a challenge for constructors of Picoballoons from all around the world. And you have radio amateurs from Germany, from US, and yeah, it's a great place for meeting people who do this. So yeah, this new probe is something very new, because all of the probes before were in the ballpark of like 15 to 20 grams. But now this one is 5 with the solar panels and only 1 with the body. So you can see on this picture the picture of the body, and you have all the important electronics there. So there's the processor, the communications module which transmit the data, all the sensors. We currently measure temperature, pressure, humidity, and wind speed by the speed of the probe, and also UV radiation, and we send it through the LoRaWAN communication system. So the ground tests of these probes went really, really well. So we are getting a result that the probes can function just from the sun. They can function for a long time, measure the data. Sadly, when we go to the next slide, so yeah, back a little. Yeah, so sadly, what happened at the previous 2 launches was that we needed to do both of the launches because they were arranged and there was a lot of people, so we couldn't really move them, but there was bad weather during both. And during both, the probe once hit the UFO, so we have a UFO.
Yeah, a little collision to the UFO, so it exists only in Slovakia.
Yeah, only in Slovakia you get that. And the second time it just crashed into the tree. That's much more boring. But we continued during the ground test, and still from the ground test data, we managed to do some improvements, and we have a version which is called version 8.3.0, and that has better GPS management, so the GPS is 8 times more effective. And we are currently testing that with the part of the team in Germany, and if everything's successful, we will launch during the start of November. And with this probe, due to its special parameters, it can fly for tens of thousands of kilometers. So that means if the weather will be, because it's with these constructions, it's also all a matter of luck as well. So if the weather is good, it can fly around the whole planet multiple times.
Yes, so and you might be asking who are the people behind it. So as you can see, there are two pictures. On the left side, you can see the Slovak part of the team, and on the right side, those are more familiar faces for you, definitely. This is the German part of the team. So, yeah. On the picture in Slovakia, you can see we are standing on the UFO, which is a restaurant on a bridge, like 150 meters above the ground. And it was a kind of successful start because we tested many things, but unfortunately, we had a collision with the UFO. So, yeah. So what are our results? We have 16 team members from 3 different countries, so Slovakia, Germany, and Czech Republic, or USA.
USA.
Oh, sorry, USA, yeah. And we had 9 successful launches, which 2 of them were kind of boring because they had collisions, but we flew more than 12,000 kilometers, or like 12,000 kilometers online. So we knew where the flow.
So we are sure that we flew around this distance, but of the probes went offline after that time, which doesn't mean that the electronics failed. It can only mean that they were in countries with no coverage. What this means is that, after that we didn't receive anything.
Yeah, but we received something very important, and those are connections with people and new partners. So we are partnered up with 13 firms or companies which support us throughout the electronics or even the building we are in now.
Well, a lot of different stuff.
Yeah.
So, for example, when we are working with the Slovak organization for space activities, which was the main partner for now, until recently, they provided this manual with a lot of people who know a lot about this subject to help us. Now with the SFN is going to help us finance the project, but also they have a lot of great students which can help us.
Yeah, and the main thing is we decrease the weight of the body, the chip, from 15 grams to just 1 gram.
Yeah, so we are.
Yeah, but that's amazing.
Yeah, go on. Yeah, and this is
the fly map. So you can see all the probes we launched. I think 2 are missing, the 2 ones that collided.
Because you didn't see that.
But yeah,
most of the launches were, as you can see, made from Czech Republic, Slovakia, and one was from Poland. The little orange ring in Poland, which is the shortest flight, that was just a testing flight done last year, which was the small probe was placed on the large latex balloon, and we tested its performance in the high altitudes. What's our vision for the technology? So I told both to the team members in Slovakia and in Germany, and also some advisors, and this is the things on our roadmap. These are the things on our roadmap. So we want to finalize the suspended probe. So now the probe, it's a suspended probe, so it's below the balloon on the tether. That's fine for now, and we are doing a lot of that stuff to protect it from the weather conditions. So the temperature and humidity are affecting the flight. So for example, you can have droplets of water form on the balloon, which make it heavier, so it goes down. But we want to develop a special conformal coating, which will decrease this effect. And we also want to protect from wind gusts because the solar panels are really fragile. So it's like silicon, thin silicon glass, and it's 1/5 of a millimeter thick. So it's really fragile. So what we did that with our material engineers, we designed a bumper which goes around the panels, and now even when there's strong wind, it can handle this.
Yeah, so for example, if you have another collision with UFO, you just fine.
Yeah, it's UFO proof.
Yeah.
And with this, the third point is it's also important for this. So we are already starting to develop a new launch mechanism, which would be basically just a single or a couple of tethers, which would connect the balloon and insert to the balloon in a certain way, so you can gradually let it up without going too much sideways.
Yeah, but that's not the only important thing. We're working on flexible chips or PCBs that could be mounted directly on the balloon, so that way we have more, we're more certain that it won't be damaged.
You have extremely high mechanical resistance, so the material is very flexible, and it's not, because when you have a probe below the balloon, it shows the center of mass, and it's behaving. You have a mass on a tether, so it's not really good with high velocity changes and acceleration, stuff like this. So that's if we would have the whole probe just a sticker on the balloon, this could help a lot. Also with the go back a little.
Oh, sorry.
With the flexible solar panels, we are thinking about putting them around the whole balloon, so that way we would have a lot of surface area where we could gain the required solar power. And we are already communicating with the companies which do this. And the last very important, the very important point here is, is that you want to work on cluster communications. So now we have some countries which are covered well. So for example, the whole we are communicating using LoRaWAN. So this is a communications network. There are about 13,000 stations that are on the whole world. But more than half of them is in Europe and in Germany. So, for example, in Russia or South America, there's much less of them. So, we will be equipping the new probes with software which helps them remember. We already have the software, which helps them remember the data which they measure during the flight on about oceans, for example. But that's still not live. But for doing some actual research, we want to make the probes communicate through themselves. So the probes will be both transmitters and receivers, and that way we could have them communicate through the whole ocean.
So like creating the bridges between those balloons.
Yeah, exactly.
Yeah. So, and what's the plan for the members, or how to develop their personal skills?
Oh, yeah. That's, we have a problem here. Yeah, the points are.
Oh yeah. So our technician is kinda. that's our. But don't worry. So the thing is, we want to give them as much information as we could, so that we can develop their skills as much as we could. For example, we have consultations with, for example, meteorology experts or professionals from electrical engineering or even space programs.
Currently we have 16 members, but we are still looking for more people from the world and from all the countries, and we want to build a team from this.
Yeah. So
we also want to organize international conferences. So each half a year, let's say when the pandemic ends, of course, which is still going to take long, that After that, we talked with the SFN, and they proposed that we could do international meetings or conferences for these members of the team. So everyone would go and meet at a certain place at one of the labs. So, for example, we will soon have new members joining in Cyprus, so we talked about that we could go to Cyprus next year.
Yeah. So those are the people that help us create this amazing opportunity for all of us. You can see SFN is the first one in the
Yeah,
it was a fun. Yeah. So thank you all. And if you want to join us or learn some more information about this project, you can visit us on picoballoon.org or scan the QR code now.
Scan the QR code. So now we should have the question, the discussion, but we would need to check the conference room for that.
Yeah.
So are the people able to speak? We should add the moderator because. So I don't know who. Oh yeah, they are in the chat. So just can you hear?
Okay, so
I don't know. Yeah. So Edward is asking. Oh hi Edward. So
yeah. So hi there, Edward. You asked for meeting agenda declaration.
Jacob, we can't hear you anymore.
What about now?
Yeah, now it's better. I can hear you again.
Yeah, is it good?
Yes.
So did you hear anything from the answer or not?
Nothing from the answer.
Or
so are there any answers? Yeah, they heard.
okay, great. So yeah, then the next question.
So the parameters we measure.
Yeah.
Yeah, so the most useful thing is for research companies or even meteorological companies. I hope I said it right.
But they're probably asking about the specific variables. So we already said this. I don't know from when is the question, but yeah, it's currently temperature, humidity, pressure, altitude, UV radiation. I think we can do both UVA and UVB, calibrate the different measurements, and then wind speed and the location of the probe. And we don't have an algorithm for this yet, but we plan to calculate the wind speed and the flow of the wind according to the location changes. But yeah, we already have some people who are interested in looking into the sensors, so we plan to measure all of the different variables like gas concentration, so that can be CO2, NO2, maybe SSO type gases, and different chemical structures.
Yeah. So Shepard is asking, what will it take to make it further around the globe?
Yeah. So definitely better weather, because with the previous launches we were forced to do them even when the weather was not great. So mainly better weather. But as we said, the bumpers could help a lot. So they are protecting the solar panels, and yeah, so that can help. But ultimately, so as I talked about the flexible probe, we hope that this kind of structure could withstand nearly any kind of weather. So when you have rain, the hydrophobic coating should be able to repel all the water from the balloon. Then we want to have, since the probe will be, both the probe and the panels will be just film coatings, or like thin films, the balloon will be able to crash, to rotate in any way, maybe not crash, but at least rotate very wildly, and still should operate. And most even of the readings should be normal. And yeah, so that's something which could make the probe resistible for anything, not maybe like lightning.
Yeah. So
yeah,
we have a few questions that are like work in progress, I think.
Yeah.
But we can see. So Alice, yeah.
Yeah. Well, why does it not get stuck while traveling? Well, flight altitude
is around 10 to 13 kilometers. So
yeah. So when you don't have very high wind gusts, when you go maybe like 10 meters above the ground, the balloon is just slowly going up, maybe 1 meter a second. So that way it doesn't, because you have the ascent phase. So that's when the balloon goes up. That's taking around maybe 1-2 hours. But then there's the floating. You have the floating phase, which is in the 10 to 13 kilometer sector, where the balloon just stays in this altitude and continues to fly horizontally. And because of the material, which is it's a film similar used to what's used with vacuum packaging. The helium does not leak, or it leaks very slowly. So that means the balloon can fly. I know some people who are doing this as a hobby, like some radio amateurs, and they have some pros who managed to fly for hundreds of days. So we are hoping to reach this very soon.
Yeah, and so with the idea to put solar panels around the balloon, do you think that you could transmit the data through the night?
Yeah. So the night is a second very challenging thing, but it would be very useful to have it functioning in the night. So before we used lithium thionyl batteries. These are not really great for the environment, at least much less than these solar panels, but they are working in minus 60 degrees Celsius, so that's very good, but they are also very heavy. But primary batteries which do not charge are not a solution, because they don't have unlimited use time. But now with solar panels, we only have a supercapacitor as some smaller storage. So it only works during day. What about night? So during night, you would need some kind of battery. And this battery needs to check a lot of various checkboxes. So you would need the battery to be very light. So maybe 1-2 grams. You would need the battery to work in both, not only discharging, but also charging. So it should be rechargeable. That's the second thing. But also it should be able to charge in minus 30 degrees Celsius. The least we measured was during the night something like minus 45 degrees Celsius. But that will not happen during the day when it's charging. And you also need the battery to have enough capacity and enough current supply. And this is really hard to get. You cannot buy it through normal shops, but you have some companies which have nanotechnologies which can work in this way. So we are hoping that with the new financing and new contacts, we'll be able to get our hands on something like this and make it work. So in the future, it can be possible.
Yeah, and what about using hydrogen instead of helium?
That's definitely also an option.
Do you think we could manage to use hydrogen, or like What's the problem with using hydrogen?
There are many paths this project can go. So this the probe and the balloon, that's kind of like a platform. So when it would be some professional use, so maybe if we could make something like this for a research team to use somewhere on remote areas, on deserts, on polar caps. There we can, or even for normal weather use and normal residential, normal areas. Not really. It's done near airports and such. And that way, definitely, professionals can use hydrogen. We maybe will have some experiments with that, but most of the launches are very public, so you have maybe 20, 30 people, and you also need the license and a lot of stuff like this, and because hydrogen is highly flammable, so that's kind of a problem. But hydrogen is an advantage, both in cost and in the lifting force, the buoyancy force, because it is lower density, but even the helium, because this balloon needs so little helium, costs maybe under €5. So it's really cheap if you worry about the cost. But for professional use, hydrogen definitely. But we are also exploring an option of having some kind of kits for general use, or maybe even something which a general person can build by themselves.
Yeah, and don't you think it's dangerous? Like,
yeah, and for that, you couldn't have students.
But after it like gets off.
Yeah.
Yeah. So for the landing part or like falling part.
Yeah, for the falling part, it may be the case, but
because it doesn't explode in the air.
We will need to do some experiments, how the deflation works, how the descent works, stuff like this. Maybe do some simulations, but it's an option.
Cool, good to know. Yeah. So, how often does the new 1 gram device measure the data? Where are the data transmitted?
So how often? In the day, the current firmware, so you can edit it. The power supply probably allows us to do it maybe, nearly continuously, so maybe every 10 seconds or so. But since we are using LoRaWAN, as I mentioned, so that's a community network. You have community stations, so both people and companies and organizations, large group of people have this mounted on their balcony, maybe sometimes in the room, but also on large radio towers. So there's it's varying, but it's a community network. So you are basically what you're doing. You get it for free, you get it for free, but you also need to follow some guidelines on the data usage. So you cannot push insane amounts of data through the network. And since we are transmitting on nearly the full power we can go, then we cannot transmit so much. So now it's set to something like 3 minutes during the ascent and descent. So there's a geo fence, altitude geo fence, so below 5 kilometers it transmits every 3 minutes, and above that each 10 minutes, I think. But yeah, it can be changed. But also, since we don't have the backlogging, so that's recording the data and sending it back after you come from an ocean, or from above an ocean, to be more specific, it doesn't transmit above the ocean, for example.
And how will be the data stored?
As
an SD card or in a processor?
For the backlogging part, we will. Now we are using a processor which is a normal Arduino core processor, and it's too small. The memory there is too small. But with the new processor, which is still very, very cheap, we will have, I think, 16 or 32 times more memory, and we will just store it in the flash program memory of the probe. If that's for the backlogging, but after it transmits data, until now we just had a simple JavaScript parser, which then linked to like a public platform for IoT displaying of the data. But now the software developers on our team are working on a REST API, which would actually parse the data, store it in a database, and now anyone could fetch the data from our servers, even from historical flights. So this will help manage everything.
Yeah, and last question for the transmission, was the maximum transmitting range?
Yeah, so LoRaWAN is also used on the classical high altitude balloons, and they've done many experiments there. And now the records are around 750 kilometers. So what's actually limiting you there is the curvature of the Earth. So you can transmit to very long ranges when you have clear line of sight. But in that altitude, the clear line of sight is never longer than that. But if we would be able to have more probes in the air, we could have longer clear line of sight between them because they are both in the air. So we could have more than 750 kilometers.
Yeah.
Maybe.
Shepard is asking if he can watch the next launch.
Yeah, definitely. So just today, I've had some, this week, I've had some frustrating experience with testing of the solar system. So I sent it for to Zenon, who is an engineer in Germany. In the German part of the team, and just today he had very good results. So maybe the next week we'll get the solar panels back. I will try to assemble the final probe, and maybe next weekend or sometime in this. And in the ballpark of the next 2 weeks, I would say we should have the launch, and this will be one testing launch. So we will maybe do some pictures, maybe live stream from that. But when this confirms and we have a functioning flight, we want to do a large launch in Slovakia, which would be a larger event with more cameras and content.
Yeah, and don't worry, the location will be like really cool. I don't want to spoil anything, but it will be a heliport right next to Danube. So you don't know. You'll see. Believe me, it'll be cool. Yeah. So
this is the last thing.
Yeah.
So this is LoRa communication network. I think you could do software updates and I mean that's interesting idea. We didn't really think about this, but it definitely would be important to have something like this when the probes would be flying for a very long time. Hard to say because at least the LoRa he knows, but he has known before, so it's fine.
So Dalimir, don't spell anything. So
that's me apparently. But now what was I saying? Updates. So at least LoRaWAN is not really a stable connection, I would say. So and the bit rate, the transmission speed is very low. So not really. But if we would have some kind of a more private communications system, because it can switch, for example, to LoRa, so we can see if the probe is flying for 2 months and we see that it will be approaching one of our stations, let's say in Germany, we can just track it, and when it's close to us, we could point an antenna at it and do the update through a direct link. I think that could work, definitely, something like this.
Yeah. So Dalimir will be quiet as mice. Yeah, mice are not quiet.
Yeah, that's a good point. Who is quiet? The snail was quiet, right?
Or maybe no, snake isn't.
Snail.
Snail is, yeah, I understand.
Did you ever hear a snail? What does the snail say? Nothing.
I'm slow.
Yeah.
Wow.
Yeah.
Okay.
So last question: do you think that once this thing takes off more, do you think that you could win?
Yeah, sure. I think that, like the more team members we have around the world, each of them can have their own LoRaWAN.
Yeah. I mean, what I started look up with the previous question. Yeah, it could be something like this, because the LoRaWAN network is really great for just sharing general data. But maybe if you would want to do some kind of more data heavy things, so maybe we could even install a camera and pull some pictures. We could do this with the stations and direct links.
Yeah, that's great. Oh, yeah. So how much we have? Okay, so we have 5 minutes. Yeah, I think there's a chance for them installing more, or I think it's community. So
yeah, actually, when you look at like the trend line, so when I joined the Things network, they were around 6,000 LoRaWAN gateways. So at the start of the 2020, it had so that's a year. It had 10,000, and now it's 14,000. So it's growing pretty fast. So we can expect them to be more and more popular.
Yeah, I hope there will be more of them in Russia or in South America. Yeah,
you did the radio regulations, which are not playing in our way.
It sucks.
Yeah. So
oh yeah, that's cool.
Thinking, do we have a recording?
Yeah.
It's not.
Oh, it's not being recorded.
That's sad.
Yeah, we need to make this every day. So where's the 1G chip available? So currently only in the store that it's called Jakub Naj.
I mean, yeah. So it's we still would need to do a lot of work to optimize something like this, and if we would want to have it public in some way, we would need to do even more work for certification. Oh no!
Yeah, so the Cisco ended. So
yeah, so you have a 10,000 euro camera system, and it just ends after an hour. So
hold on.
Let's.
Yeah, so let's switch to the PC. Yeah, you can see this is our setup right now. So we have 2 huge monitors, lights everywhere. Yeah. It's kind of
okay. Let's continue. So yeah, I answered that.
Yeah, but I think we need to make it more available in the close.
Maybe get this somewhere. Right. Okay.
Yeah. So bring the chair.
Is there something else? Okay.
So if you have any more questions,
yeah, Shepard is typing again. Shepard is interesting.
Shepard is on the streak.
Maybe. Yeah.
Yeah, I get somewhere around 3 hours a day.
Let me check.
Yeah.
Yeah. So that's my heart rate.
He's just flexing with his new watch. So
yeah.
Don't worry about him.
Yeah, 5 hours. That's fine.
Yeah, that's fine. Yeah, and imagine the school. Yeah, it's kind of crazy. Yeah.
But we work from the office. We're in their office.
No, we are learning from the office.
Yeah. We are schooling, online schooling from the office.
Yeah.
Yeah. So the silver suit, that was
that was his girlfriend.
It was if you consider like a Slovak non-profit organization
as your girlfriend, yeah.
If that's possible, then yes. but it was from the Slovak organization for space activities. They just have this costume at the third launch. It was just there, and I used it, and then it became kind of like a symbol, and I used it for or a meme more like a meme. It was a good way to get people's attention and then tell them something about Picoballoons. But
yeah, the media were crazy. So they thought there's an alien or a cosmonaut in Slovakia.
Like, is it for fire protection? Or but now we want to keep it more professional. We have this brand, we have the website, and there is more people. Not everyone can wear silver. And it's not about me anymore.
Not everyone is Jakub, you know.
Yeah. So and thanks, Shepard.
Yeah, it means a lot. Okay, so if you don't have any more questions, I think we should be done.
Someone is typing. Yeah.
Oh yes, another question.
It's a question streak.
We need to make podcasts. Thanks, nicely done. Thank you so much.
Yeah, I will also say thank you to you. That was a very good presentation, and I hope, that someone perhaps will join you, and perhaps you can keep in touch. I think Picoballoon, there's some information so how the people here can get in touch with you.
Yeah, so on the website, we have an email. We also started some social media, so Instagram, Facebook, and YouTube. So we will post regular updates, launch videos, stuff like this there. And on the website, you have, you shouldn't learn more than you learned today, but because there it's really simple. But in the Join Us section, you can find a form where you can join the project.
Yeah. Tomorrow there's an.
Oh yeah. I forgot. So tomorrow we firstly wanted to do 2 workshops, but there is going to be only one. So tomorrow, me and Zinan will give a workshop on hardware design. So to give the people who want a taste of what the electrical engineers are doing. So it will be about a 2-hour workshop about working with Eagle, which is a program for CAD electrical design, and we will go through from the basics, from creating a schematic to drawing and routing a board and creating Gerber files for manufacturing PCBs. So if anyone here either is interested, but also
there's a lot you can learn. Yeah. Okay, great. So.
So if you like this presentation, you can join them tomorrow again, and I hope every question could be answered, will be answered tomorrow. Yeah, thank you very much for the presentation. It was very good. A good overview over the project. Thank you very much.
Thank you so much for the opportunity.
Yeah. And hope to see some of you tomorrow.
Yeah. Bye-bye, guys.
Goodbye.